Okay, so now let's learn how do we apply these BRDFs in our ray traces, and what kind of changes do we have to make compared to the basic reflection models that we have been using so far. Now, I would like to remind you the FONG model first, okay? Maybe we didn't use this model in our ray traces so far, but it's really one of the simplest models. And Blin FONG, the one that we have been using, is a modification over this model. So the original FONG model works like this. So you have the surface normal, and you have the incoming light direction, okay? And let's say this is the weaving direction, the outgoing light direction. So in the original FONG model, we reflect the incoming light around the surface normal. Okay, so we call this WR, the reflected one. And you use this angle here. Okay, let's call this alpha R. Okay, so actually the specular component is related to like cosine alpha R to the power of this FONG exponent. Okay, so this is the FONG model. Now in the Blin FONG we were doing something different, and I will mention that. But in the Blin FONG, you compute the half angle. So this is the FONG. In the Blin FONG you compute the half angle between WO and WI, right? So let's say this is WH, and then you use this angle. Okay, so let's call it alpha H. In the Blin FONG we use cosine alpha H to some power FONG exponent. Okay, so this was FONG and this was Blin FONG. Now how do we use these things in our ray tracer? So for the basic FONG model we have been doing the following. The outgoing radiance is equal to some KD times cos theta I, okay, and then plus KS times cosine, let's use the FONG one, alpha R to the power of pi, okay, times what we were doing, times, so this was the diffuse component, okay, so remember this was the diffuse and this is the specular. I'm not including the ambient term here. So diffuse specular, and we multiply this with the incoming radiance, right? L WI. Okay, so this was what we were doing. Maybe we were doing this separately. We weren't combining this. Okay, you could be computing the diffuse first and then adding the specular to it. But the net effect is this. Now let's also remember the rendering equation. In the rendering equation, we have LWO is equal to, for all incoming directions, F WI WO. Okay, and then we have L WI cos theta I and then DWI. Okay, so actually this BRDF now somehow this combination here should match this combination here. Okay, now for that to happen, if you actually write your FONG BRDF as follows: F WI WO is equal to, okay, I will write it as a function of two things. So if you write it as KD, okay, plus KS divided by, okay, cos theta I divided by cos theta I, and then cosine alpha R to the power of pi. Okay, when theta I is less than or equal to 90 degrees, and 0 when theta I is greater than 90 degrees. Okay, now if you take this BRDF like this and put it into the rendering equation, okay, if you take this one here and plug it into this F term, you are going to get the identical results to the earlier shading model that we have been using. Okay, so this is known as the FONG BRDF.